Math 1700. This is a really cool video, and I know you're thinking, Darbo, you're such a geek. Uh, yeah, okay. I got nothing for you. I am. But what we're going to do in this video is we're going to look at a couple of things. First of all, I want to talk to you a little bit about systems of linear equations. And I'm not sure that I'll get into it in this video or not because I never know how long I'm gonna how long I'm gonna talk. But we'll ultimately look at solving systems of linear equations a new way using matrices, and it's really cool. I mean, it's cool because it's a new mathematical object, if you will. Uh, it's a new technique. It honestly, it makes things easier. It really does. It makes some of the stuff that you've done in previous math courses easier. Now, if we just to give you an example of it's kind of hard to get started here because I'm trying to think where I want to head with this because I don't use notes and stuff. I just kind of shoot from the hip. Let's say probably somewhere in the past you have seen, I don't know, something like a problem like this. Let me do something that will have a nice kind of neat answer. Okay, and there we go. That thing collapsed on me again. I don't know why that happens. And typically we look at these things and they have kind of a bracket kind of thing in front of them. And the goal here is to solve the system of equations. Now, what we run into here is you can see that we have two lines. We have two equations. We have 2x plus y equal 8 and x plus 3y equal 9. Systems of equations come in three forms. First of all, again, you can think of this as just being a line, and let's just call that L1. And then we might have another line that comes in like this. Let's call this L2. So the solution to a system of linear equations is just the point that the two lines cross. Now, sometimes you get into parallel lines. For example, I'll try my best to draw two lines that have the same slope. So in this situation, L1 and L2, there would be no solution because with parallel lines, obviously the lines don't cross, so there's no solution. This is a unique solution. And in the business world, in finite mathematics more specifically, these are the types of systems of equations that we're going to run into. And there's one, just to be very thorough, there's a third kind of form too. And that would be where you have L1 and then you have L2, pretend I drew that right on top of that, where L1 and L2 are the same line. And in this situation, you would have infinitely many solutions because every single point that you have is a point where the line actually crosses because it's the same line. So there are these other three. We're not going to worry about those as much in applications. We're going to focus on this one right here. Now, I just kind of curious. This is something I do when I'm teaching in class. Is I just kind of throw it out to my students. How would you solve something like this? And I just want to run through some of the things that you probably have seen previously. First of all, you could use a method like this. So if we have 2x plus y equals 8 and x plus 3y equals 9, what we could do is we could use the elimination, well, actually the addition. And we could see that if we multiplied this second equation through by -2, what would happen is we would get a 2x and a -2x here, so we could eliminate temporarily the x term and focus on the y term. So if we were to implement something like this, we would get 2x plus y equals 8, and we would get -2x -6y equals -18. Now, as we've talked about a little bit before, I think we talked about this a little bit when I was teaching exponential functions. We can add all the stuff on the left-hand side and add all the stuff on the right-hand side because they're equal. So if I add all this stuff over here, I get 2x minus 2x, which gives me 0x, so that eliminates. And then I've got y minus 6y, which we should all know is -5y. And then over here I get 8 minus 18, which is -10. So I'm going to divide both sides by -5. And I see that y is equal to 2. Now I can choose one of the equations that I started out with. I'm just going to choose this one, the 2x plus y equals 8. But I know that y has to be positive 2. So I can make this 2x plus 2 equals 8. I think we all see that that's going to be 2x equals 6. Divide both sides by 2, and we see that x has to be equal to 3. So our solution, therefore, will always be an ordered pair in the form x comma y. So our solution in this problem would be 3 comma 2. Okay, now this is what we call the addition method. And it's fine. There's nothing wrong with the addition method. It takes a little bit more work. I just happened to come up with a really easy problem here. But, you get into fractions, and those things become a little more challenging to do with the addition method. Okay, so my goal here is to make it easier on you, believe it or not. Now, another way that I want to talk about here, just to point out and reinforce that the solution to these things truly is the point of intersection. What I could do is I could take this 2x plus y equals 8, and I could put this in y equals mx plus b form. Now this is a really cool form to get any linear equation in, because we know very quickly the slope is -2, and we know that the intercept is positive 8. Now I've got to work a little bit harder on the x plus 3y, because there's going to be an additional step, because the leading coefficient of y is not equal to 1. So what the first thing I would do here is I would have 3y equals -x plus 9, and then I've got to divide through each term by positive 3. So ultimately, guys, on the left side I get y. Now students sometimes flip out on this. What's this -x over? I like to keep things where we have a coefficient in front of the x, and we can just think about this as always just 1x. So I would think of this as -1/3 x plus, and of course 9 over 3 is just positive 3. So what I have is I have two equations. Y equals -2x plus 8, and y equals -1/3 x plus 3. Now if I can graph and find the point of intersection, then what do I have? Then I have the solution. I have the solution to this system of linear equations I started with back over here. Now, that turns out it's really easy to do since you've got that fancy schmancy calculator that I required you to purchase. So all I have to do is go into y equal, and I want to get rid of the previous problem because it's no longer relevant. So if I go negative 2x plus 8, and then I'm going to go negative 1/3. Now guys, I'm going to tell you, when we're plotting graphs with fractions, go ahead today and get in a habit of putting your fraction in parentheses. So I have negative 1 divided by 3 times x plus 3. Now, when I have a generic problem like this, what I can do is just do what's called zoom standard, which is going to give me my negative 10, positive 10 on the x and the y. So I'm just going to go to zoom and come down to number 6, which is zoom standard. And what's going to happen is it's going to graph the two functions on the same, or the two lines on the same graph. So if I can tap into where these two lines intersect using my calculator, then I can get the solution. Now guys, if you got an error, and I talked about this earlier in a video, but if some reason you didn't watch it, which would be shame on you, if you got an error, you might have to go second function stat plot and turn these things off. So I'm just going to go 4 plots off and hit enter where it says done, and then I'm going to go back to what I had, go back to zoom 6, zoom standard, and I shouldn't get my error. Sometimes if you haven't turned your stat plots off, it'll give you an error, and those kinds of things can be extremely frustrating for an online course like this, because I'm not going to come to your house and fix your calculator for you. But you can always, again, do Google Hangout. All you got to do is say, hey, Dr. Darber, I need to hang out with you, man. These linear functions are driving me insane. I need some more help. You've also got the option of going and seeing our graduate assistants who are in the math lab every day from about 8 to 4. They're really good. One's a local high school teacher. Both of them are working on their masters. Another just graduated from University of Wilmington. Her transcript is all A's. It's amazing. These are smart people. They can help you, and they're convenient. But if you work all day long and you need to have a Google Hangout session at 7, 8, 9 o'clock at night, then sometimes I'm available for those. Okay, or just rewatch videos, because everything that I'm going to ask you to do, I will teach you in the videos. I'm not going to require you to do much independent. One more thing before I go on to this. I'm kind of a tangent here. Something I have done, and let me write this here. All assignments from here on out, I've given this some thought, and I'll explain what's going on here. So your My Math Lab assignments are going to be changed the due date. The new due dates are on Monday. Okay, so Mondays at 11:45 p.m. Now, the reason I did this, they were typically due on Sunday. And I know the nature of students, because I was a student for many, many years, is to procrastinate, put things off until the last minute. And what I was having is I was having these things due on Sunday. And guys, I don't work on Sunday. Sunday is what I call my F day. It's not that I fail on Sunday, although sometimes I guess I do. But no, seriously, all kidding aside, Sundays are for F. It's for my faith, my family, and have some fun. Go out on the boat. And yesterday we went on the boat and the girls swam, and we had some friends hook up with us on our pontoon. And so, so again, start going to church, get home from church about 12:15, 12:30, depending on how windy my preacher is that day. I have family time and I have a fun time later in the afternoon. So I typically don't work on Sunday. So I typically don't check my email. Although, you might say, well, Dr. Darbo, you answered a question for me one Sunday. Well, maybe we're getting ready to go out on the boat and the girls are taking too long putting on their swimsuits or getting their lunch together, whatever, and I just get on the internet. But it's not going to be something I'm going to do regularly. So, guys, because of that, if you ask me questions on Sunday, chances are I'm going to be involved in my F's. Again, my faith, my family, my fun. And I'm not going to get to your question. If it's due on Monday and you procrastinate, you have the option of going and seeing one of the graduate assistants in the math lab. Now, if you've never been to the math lab, this is kind of the way the math lab works. You've got Massey Hall, which is connected to the administration building. Now, my office is actually in the administration building. But if you come down the hallway, as soon as you go into the administration building, you're going to see the dean's office on the right. After you go past the dean's office, you're going to see a hallway that goes down to the left. The math lab is this room right here. Now, if you come on down, go back in here, you come into the math offices. That's where my office is. But since I'm teaching all online courses this summer, I'm not on campus as much as usual. So, office hours will be online. But the best thing to do, if you want help at your leisure, is go to the math lab and let either Allison or Melissa help you. They can definitely help you with what we're doing in this class, at least for now. Now, we're going to get into some stuff. We're going to get into some cool stuff. We really are. Once we get into the math of finance stuff, I don't know how many business students I have that'll contact me and they're like, Dr. Darbo, that was the best part of any class I've ever taken at Shawnee. That's cool stuff because it's stuff that you're definitely going to use. All right, gang, I think we call that a tangent. So let's get back over here to this calculator and figure this out. So I'd like to find that point of intersection. So I can go second function, go up here to calc. The beauty of this is when it turns red, that's the button that I clicked. If you come down to number 5, that's the function that will find the intersection of two lines, if the intersection does exist. Now, what happens here? And let me go back over here and show you what's going on with this. Let's say that, for example, we had a situation where we had a graph, and we had another graph, and we had another graph. So we essentially have 3 lines or 3 functions that have been graphed. Now, let's say that we want to come in and find the point of intersection for those 2 lines right there, those 2 points, that one point for those 2 lines. This one right here, that's irrelevant. We don't want to select it. So I would need to select that line, and I would need to select that line, then come in and kind of hover over this point, and we'll call that a guess. Guys, I swear I can spell guess. That's just horrible. We're going to make a guess of our point, and then we'll hit a certain button, and it'll actually find the point of intersection. So we don't really run into this because we don't have this third graph here. But anyway, I'm just letting you know why the calculator appears to make things harder. So my first curve, that's the one we want, so just hit enter. The next curve, that's the one we want. Okay, hit enter again. Which 2 curves do we want? That's irrelevant when we only have 2. That's going to change next week, but that's the reason I'm pointing that out. And then we're going to come over the guess, and they spelled it correctly. I can spell. I just get sloppy sometimes. So I come over and kind of make a guess and say, well, of all the points of intersection there could be, that's the one I want. And I hit enter again, and you'll see that you have the point of intersection when the intersection command right here pops up. Now, back when it was guess, we still had some decimals. We didn't have the point of intersection. But now we do, and we see that the ordered pair is, of course, 3, 2. All right? So not difficult, but that kind of stuff would be tougher if you ran into something with fractions or decimals, which we ultimately will. All right, gang. Let me show you another way of doing these types of problems. Called matrices. Now, a matrix is a collection or an array of elements. This matrix collection of elements, and guys, when I say elements, I'm just being math geeky here. Usually our elements are numbers. These things have m rows and n columns. So from this, what we create is an m by n matrix. And this is pronounced m by n. So when we see that cross right there, that's actually saying by n. So if we have a 2 by 3 matrix, and matrices are usually named with capital letters, so we may say that the matrix A is a 2 by 3 matrix. All this is telling us is we have 2 rows and we have 3 columns. So a matrix is given by brackets, like this. Okay. So -3, 4, 2, 0, 1/2, pi, if I get real weird here. These elements that I talked about back here, again, are typically numbers. So because we have 2 rows and 3 columns, this matrix, which we could call A, is a 2 by 3 matrix. Okay, so it's that simple. Now let's say that we have a matrix B. Which looks like this. Well, notice this has 1 row, 2 rows, 3 rows, and 1 column. So we would say that this is what? A 3 by 1 matrix. Now, when something only has 1 column, sometimes we refer to this as a column vector or a column matrix. I'll let you get away with that. Now, what if we have another matrix C? It looks like this. Well, as you would expect, we have 1 row and 4 columns. So what size would this be? This would be a 1 by 4 matrix. Now, when we have something that only has a row and multiple columns, 1 row, it might make sense to you, and it would be correct that we call this a row vector. Now, guys, we don't run into row vectors and column vectors very often. Not in this class because we're looking at things that are in applied nature. But what matrices allow us to do? It allows us to organize information. It's really cool for things like inventory. Let's I don't know. Let's say that we have I used to own a golf course, so some of the things that I do may be golf course related. So let's say that I have some drivers, and I have left-handed drivers and I have right-handed drivers. And let's say I have 3 of those in stock and 14 right-handed in stock. And then I have putters, and I have left-handed and I have right-handed. And let's say I have 1 of those and 5 right-handed putters in stock. Well, what I could do here is I could create a matrix where I have drivers and putters and left hand and right hand. So I would have what, 3, 14, and 1, and 5. So I could create very quickly what I would call here an inventory matrix, which just very quickly organizes the information, and it allows us to do some stuff that we'll end up doing with matrices here. Okay? So guys, still pretty easy. Now, matrices kind of behave like numbers, sort of. And we can examine operations on matrices which have helpful features for us in a class like this. For example, I said earlier that matrices work kind of like numbers. Well, if I have 2 numbers, 3 and 2, then I can I can add. Isn't it comforting that your math professor doesn't know the difference between adding and multiplying? I can take 3 plus 2 and get 5, so I can add these. Well, you can add matrices sometimes, not always. And the condition on being able to add and subtract, so we'll put all this to be able to add and subtract matrices must be same size. In other words, they must have the same number of rows and the same number of columns. So guys, if I take a matrix 1, 2, which would be a column vector, so this is clearly a 2 by 1, and I want to add to it this matrix right here, which is a 2 by 3. Can't do it. All right, matrices have to be the same size. Now, when we get to matrices that are the same size, it turns out that adding these things is very simple. So if I want to you guys are going to get tired of looking at my hand and arm. If I have something like this, where I have a 2 by 2 matrix and I want to add these, it turns out, guys, it's really simple. This, again, is a 2 by 2 matrix. So the addition of these is going to result in a 2 by 2 matrix. And the components of that just turn out to be really related to position. We add the upper left to the upper left, upper right to the upper right, bottom left to the bottom left, and bottom right, bottom right. So the sum would just be the sum of the components. Now, so guys, this is an example of adding. We could take the same elements here, same matrices, and we pretty much do the same thing when we subtract matrices, as long as they're the same size. A 2 by 2 results in a 2 by 2. So I would go 1, minus a minus 7. This position, 0 minus 8. Position and position, so I go 3 minus 1. And I go negative 4 minus 4. So the sum, the operation of subtraction on these two matrices, again, because they have the same size, would be this. Now, it turns out, before we get into the tough stuff, it turns out that we can do this kind of stuff on our calculator. Now, guys, this is a place where I think taking this course online is going to be better, and let me get my stuff over here all set up. I think it's going to be better and more efficient than taking this in class. What happens in class sometimes is I go a little bit too fast working the calculator, and students sometimes they look at it and they go, oh yeah, I can do that, and then 4 or 5 days later they start to do their homework assignment. And they're like, I don't remember. Well, guys, you have this on video, so there's no reason for you not to be able to repeat this. Now, what I want to do, I just want to get out of all this and get a blank home screen, because that's just the way I roll. I like to start out with. All right. So, guys, right over here where I am, if you look on, come down, find your green key and come down 2, you'll see a key that says x to the negative 1, and right above it you'll see matrix. So if I hit second blue, I go into the matrix editor. Now, you guys may already have some matrices there. That's fine. Don't worry about it. If you've got something here that shows that you've got some matrices that have already been edited and stored in, that's cool. But what I want to do before I do anything is I want to name my matrices. So again, the calculator gives you the option of naming these things capital letters. So what I'm going to do over here is I'm going to name this first matrix A, and I'm going to name the second matrix B. Now I'm going to show you how to put these things in your calculator. So to call the first one A, what I want to do is I want to go over to Edit. I want to select it. And the first thing it does, it allows you to set the size of the matrix that you want to enter. So I'm going to enter a 2 by 2 because that's the size of the matrix I want. So guys, now I'm just going to type in my numbers. And if we put a negative, guys, remember this negative right here is a subtraction. This negative right here, the one that just turned green, is the way we... Okay, so I enter that and I see I have the matrix that I want. Now I've got to go second function quit, go back into matrix, go back over to edit, and come down to B and name my second matrix. So it is also a 2 by 2. And this one has a negative 7 in the upper left-hand part, an 8 in the upper right, 1 in bottom left, and a 4 in bottom right. Now, what I want to do now is I want to go second function quit and get out of that. Now I want to look at adding the two matrices. Well, to do any operation on the matrices, I have to go back into the matrix. And now I've got my 2 by 2 stored in as A and B, and later on I can overwrite that. But I want to see the addition, so I just select that. It's going to kind of copy and paste that into the home screen. I want to add, so I got to go back into the matrix, come down and get B, and add it. Okay? Hit enter, and you'll see that we get negative 6840, just like before. Now, a handy dandy feature, if I want to go back up and get something previously, on your calculator where I'm circling right now, where the red is enter, you'll see entry. But it's blue, so if I hit blue enter, I'm getting what's called the entry command. And what that allows me to do, it allows me to go back in to a previous command, bring it down, and edit it. And that's really cool because what I want to illustrate now is just A minus B. And I've got the form A plus B, which means I would only have to change the operation. So anyway, guys, when I do that, you'll see that I get 8, -8, 2, -8, just like we did before. Now, you don't necessarily have to do this. It's totally up to you. But let's say, for example, that I came in and I wanted to create a third matrix. And this thing is a 2 by 3. And I tell you what, I do want you to do this because this is something that I'm going to do in just a second. Sorry, I had to get some coffee. So we're going to bring in a third matrix, and I'll tell you what, I'm going to write this down because I'll never remember it. And let's call this C matrix 1, 2, -3, 4, 0, and -1. Now, just for example, just to illustrate, let me show you what will happen. Let's say I wanted to add A and C. Now, is it going to do it? No, it's not going to do it because they're different sizes. And it'll tell me that. It'll tell dim mismatch, which says, you have a mismatch in the size of the matrices, and you can't add matrices of different. So I can hit go to, and I can say, well, I messed up there. And it's actually trying to show me what went on. So I can just clear that out. And, well, I'm going to have to quit just to get out of that. So it tells me an error because I tried to do something that is impossible. Now, guys, we don't talk about dividing matrices, but something that I want to illustrate to you is how we multiply, because we do in this class multiply matrices quite a bit. And multiplication of matrices is harder. It just is. It's quite a bit harder, but I want to show you how we multiply matrices. If we're going to multiply a matrix A and B, and let's say that matrix A is an M by N matrix, so it has M rows and N columns. And let's say that B is a R by S matrix. It has R rows and S columns, okay? To be able to multiply, a couple things have to happen. First of all, N has to be equal to R. These two numbers right here have to be the same. Have to be. It's kind of like adding matrices. They have to be the same size. The A and B don't have to be the same size, but the number of columns has to equal the number of rows of the second matrix. So the number of columns has to be equal to the number of rows of the second matrix. It's kind of cool that the size will be equal to M by S. So these two numbers right here determine the size of the resulting matrix. Now, you probably think that's really confusing. Guys, trust me, you're going to get good at this. 1700 level students seem to always be pretty good at this. Now, let's take a couple of matrices. Let me go back here, and so we had 1, 0, 3, -4. And then we had 1, 2, -3, 4, 0, 1, 2, -3, 4, 0, negative 1. You guys hear the rain? I teach back here on the back porch, and there's a metal roof. In fact, it makes me want to go to sleep. Okay. All right, gang. So what we have here is we have a 2 by 2 matrix, and here we have a 2 by 3 matrix. Are these two center numbers the same? Well, that's kind of a duh question. Yes. So that tells me what? The product exists. We can multiply these two matrices. Now, what happens is I concentrate on this number, and this tells me that my product, the product matrix, is going to have size 2 by 3. So I know that my product matrix is going to be a 2 by 3, so it's going to look like this. It's going to have 2 rows. And 3 columns. Now, guys, a lot of times students will say, well, Darbra, I know you're going to show us how to do this on the calculator. And I am. But there's going to be certain situations and applications of these matrices where even though we're going to be able to multiply 2 matrices, they won't have a values that are interpretable or meaningful. So we have to refer back to kind of the principles of being able to multiply these things. So let's go through one of these by hand, and I'll show you very quickly how to do these on the calculator. Okay. So what happens right here? If we focus on this row 1, column 1, what number goes there? Well, this is going to be a linear combination of the rows from matrix 1 with the columns from matrix 2. It goes back to this. Rows come from matrix 1. The columns kind of come from matrix 2. We combine that stuff to make the product matrix. So what I would do on row 1 is I would concentrate on the linear combination of my row elements with my column elements. So guys, doing that, what I would do is I would take the first, and again, I'm focusing right now on this, row 1, column 1. So I would take the first element times the first element plus the second element times the second element. So 1 times 1 is 1. 0 times 4 is 0. So guys, I put a 1 there. Now, what I want to do now is I want to focus on this one right here. What would go right there? And again, we've got our matrix 1, 0, 3, negative 4 times the matrix 1, 2, negative 3, 4, 0, negative 1. So let's focus on this one right here, just to kind of break things up to give an indication of what's going on here. This number right here comes from row 2 and column 2. So I'm going to take the first two, the first element in row 1 times the first element in the first element in row 2 times the first element in column 2 plus the second element in row 2 times the second element in column 2. So guys, I know a 6 goes right there. Let's jump up here and look at this one. What makes up this element right here? Row 1, column 3. So I got tunnel vision on row 1 and column 3. First element 1 times negative 3. Second element 0 times negative 1. Negative 3. Guys, see if y'all can do this one right here. Pause me and see if you can come up with what would go in that spot right there. Okay, pause me and come back. What makes up this part? Row 2, column 3. Usually I don't do this because I don't want to mess up my drawing, but first element times the first element. Second element times the second element. Add these. Negative 5. This one right here, row 1, column 2. We can get real quick now. Row 1, column 2, 2, 0. And this one right here is row 2, column 1. So we have 3 times 1 is 3. Plus negative 4 times 4 is negative 16. Negative 13. Now, if you're sitting there thinking, Dr. Darbro, that makes my head hurt, okay, remember, we have this stored in our calculator, don't we? Sorry, that wouldn't. It was actually A times C. So let's get out of here and go to the calculator and see how this would actually would happen. So again, go to Matrix, select A, go to Matrix, come down, select C, hit Enter, and you'll see we get 1, 2, negative 3, negative 13, 6, negative 5, just as we did by hand. Now, let's go back. What would happen if we multiplied the other way? What would happen if we tried to multiply instead of A times C? What would happen if we tried to multiply C times A? Well, C was a 2 by 3. And A was a 2 by 2. All right? This number and this number have to be the same. Well, guys, last time I checked, 3 isn't equal to 2. That really annoys me. It's such a simple thing, but it just annoys me when the kind of the auto-tune. Guys, when we go into our calculator, if, for example, I'll come down and choose Matrix, C times A, what do you think is going to happen? It's going to give you an error because you can't multiply matrices like that. All right? Well, gang, that's the end of this video. We're getting ready to go some cool places with this. The next video, I'm gonna get into something really cool. Called, well, shoot, I'm sitting here writing and you guys can't even see what I'm writing because I'm a dingbat. In the next video, we're going to get into augmented matrices. And in the next video, we'll get into applications. Now, Well, that's it. I'm going to end this video here. Guys, take care.